The cleanup pass behaves normally at first.
Then the processed waveform stops matching the raw signal underneath it.
One pulse arrives slightly early. Another disappears entirely from the cleaned track while remaining visible in the original spectrogram beside it.
Nobody reacts immediately because the audio itself still sounds stable.
The checksum approval remains unchanged across both files. Only the timing drifts.
The cleaned waveform starts drifting away from the raw signal before anyone says anything is wrong. One version keeps a steady pulse across the monitor.
The other drifts slightly wider after the second cleanup pass, even though the same audio is still playing underneath both recordings. The deep space signal is already old when it reaches Earth.
A timestamp beside the spectrogram marks the transmission as more than 40 light-years away.
Whatever created it happened decades earlier. The recording in the room is not live contact. It is delayed evidence arriving long after the original event is already gone.
Black background noise moves across the spectrum like static rain. A narrow frequency line stays perfectly stable through the interference. After the first filter pass, a faint repeating pulse becomes audible inside the hiss. Nobody reacts immediately. The cleanup appears to work. Then the waveform changes again. The pulse spacing shifts after the second pass, even though the frequency center never moves. Technicians replay the raw recording beside the cleaned version on split monitors. The audio no longer matches its own source. One pulse arrives early. Another disappears entirely from the processed track while remaining visible in the original signal. For several seconds, the room stays quiet, except for the looping transmission.
The problem is no longer noise.
Every attempt to stabilize the recording changes the structure people are trying to study. The cleaned version becomes clearer and less trustworthy at the same time. A restricted transmission log opens on 3 different archive systems at the same time. The deep space signal keeps the same archive label, but not the same timing structure. Every panel shows the same transmission ID, the same timestamp, the same checksum approval screen from the original radio archive. For a few seconds, the records appear perfectly aligned. The first copy plays for just under a minute. A faint pulse repeats at steady intervals beneath the static. Someone marks the pulse count directly onto the waveform display. A second archive returns the same signal less than a minute later. Same frequency label, same restricted classification. But one extra pulse appears near the end of the recording. The timeline stretches slightly farther before cutting to silence. Less than 2 seconds separate the files. Nobody speaks immediately because the difference is small enough to look accidental. The third copy loads beside both of them. This version ends earlier than the others. The final pulses never arrive at all. The duration marker stops short, while the transmission ID remains unchanged across every database window. The earlier cleanup failure starts looking different now. The signal may not have changed during processing alone. Different systems may have preserved different versions of the same recording long before anyone compared them side by side. The archive screens stay open, while the timelines refuse to align. After the muted section is removed, the 3 timelines finally align. The signal only stabilizes after part of it is excluded. A technician drags translucent markers across the archive display and isolates one narrow section near the center of the transmission window. The restricted band turns gray. Audio inside it disappears instantly. Nobody reacts much at first, because the remaining signal finally behaves normally.
The pulse spacing aligns across all three versions. Timing drift disappears from the archive comparison. A data reduction workflow begins generating one stable decode pattern from the cleaned sections, while a confidence meter climbs steadily upward beside the screen. For the first time, the signal looks manageable. The decoded structure repeats cleanly across every archive copy once the muted section is excluded from analysis. Less than a fifth of the transmission window stays blocked out, about 17%. The rest stabilizes almost immediately. The room becomes quieter after that. People stop replaying the mismatched versions because the comparison no longer feels broken. The timelines hold steady. The decoded pulses remain consistent through every pass. The gray section stays visible underneath the aligned signal the entire time. Nothing inside the restricted band is removed from the screen itself, only from the interpretation. The stable decode continues playing for several more seconds. Nothing appears wrong at first. The pulse pattern repeats cleanly across all three archive versions, while the decode confidence meter remains high beside the screen. The explanation still fits the evidence that remains visible. Then the muted section is restored. Restoring the missing section breaks the stable decode almost immediately. The gray band fills back in across the center of the transmission window. Audio returns inside the restricted range. Within 4 pulses, the alignment begins drifting apart again. Not violently, just enough to break the pattern. The clean timing structure starts sliding out of sync, while the raw frequency line stays perfectly steady underneath it. The decode confidence meter drops in small steps as the restored band passes through the system. The explanation from earlier remains pinned beside the display, even while the pulse spacing stops matching its own model. Nobody removes the restored section a second time. The comparison screen stays open, with both states visible together. One version stable but incomplete. One version complete but unstable. The earlier confidence now looks dependent on the missing section staying removed. The system did not fully decode the transmission. It only held the signal together after the part causing the mismatch was excluded from analysis. All versions of the transmission are stacked onto the same screen. Raw signal, cleaned signal, archived copies, muted sections, restored sections. Every waveform traces back to one transmission event more than 40 years old. The same restricted ID remains fixed above all of them. No surviving version of the transmission still behaves like a reliable original. One frequency line stays perfectly centered across every recording. Everything else shifts around it. Pulse spacing widens in one version, compresses in another, then disappears entirely inside a restored band that no longer aligns with the cleaned decode beside it. A baseline search begins automatically through the archive system. The display scans raw spectrograms, checksum records, restricted data layers, and processed copies looking for one stable reference track. The search window remains open longer than expected. No original version is returned. Only derivatives. Every earlier failure remains visible at the same time now. The cleanup changed the structure. The archives preserved different timings. The stable decode required missing information. Restoring the missing section destroyed the explanation again. The transmission may not have been the only unstable thing in the room. The archive changed around it too.